Welcome to my channel. This is GeoMethod, where we turn tricky geometry into clear, simple steps. Here is today's challenge. Can you find the radius of the circle? Take a moment to look at the figure and see if you can spot the idea. Then stay with me, and we will build the full solution together, one move at a time. A circle carries the chord AB of length 26. From B, a short step segment BC of 12 runs to the right. Then a long rise segment CD of 36 climbs back up to the circle. The radius R is the quantity we must find. Look closely at which corners actually touch the circle. The points A, B, and D all lie on the circle, while the corner C sits inside it as the elbow of the staircase. 3 points on a circle fix that circle completely. Draw the 3 radii from the center O out to A, out to B, and out to D. Because those 3 points sit on the circle, the radius from O to A, the radius from O to B, and the radius from O to D are all the same length R. Pinning down the center, therefore pins down R. The 2 turns of the staircase are square corners. Segment AB is vertical and segment BC is horizontal, so the angle at B is 90 degrees, and likewise the angle at C between segment BC and segment CD is 90 degrees. These right angles let us lay down clean coordinates. Put B at the origin, extend segment BC as the x-axis, and extend segment BAI as the y-axis. Then A sits 26 straight up, C sits 12 to the right, and D sits 36 above C. Coordinates turn the geometry into algebra. We do not yet know where the center sits, so call it K, H. The horizontal coordinate is K, and the vertical coordinate is H. Once we have those 2 numbers, the radius is just the distance from O to B. Drop a perpendicular from the center O straight to the chord AB. Mark its foot M on segment AB and draw the segment OM. This is the key construction, because the perpendicular from a center always meets a chord in a very special place. A perpendicular from the center bisects the chord, so M is exactly the midpoint of segment AB. Half of 26 is 13, which means the lower half segment MB measures 13. That is our first leg. Because O sits on the horizontal line through M, the center's height above B equals the height of M, which is 13. So H is 13. 1 coordinate down, 1 still to go. Now write the squared distance from the center to B in coordinates. With B at the origin, segment OB squared is simply K squared plus H squared. Hold on to this expression. We will match it against another radius. Do the same for D at 12, 36. The squared distance segment OD is K minus 12 squared plus H minus 36 squared. This is the second radius, and it will pin the center sideways. Since B and D both lie on the circle, segment OB and segment OD are equal radii, so their squares are equal. Set the 2 expressions equal to each other. This single equation is what will hand us K. Substitute H equals 13. Then H squared is 169, and 13 minus 36 is negative 23, whose square is 529. The height is now baked into the equation. Expand K minus 12 squared into K squared minus 24K plus 144. Writing it out fully is exactly what lets the K squared terms on the 2 sides meet and cancel. The K squared on each side cancels. On the right, 144 plus 529 is 673. leaving 169 equals negative 24k plus 673. Move the constants across. 24k equals 673 minus 169, which is 504. Divide by 24 to get k equals 21. The center is now fully found. That horizontal offset k is exactly the length segment OEM, the distance from the center straight out to the chord AB. So segment OEM equals 21. Now both legs beside B are known. Look at triangle OMB. It has a right angle at M. Its two legs are the half chord MB of 13 and the offset segment OM of 21. And its hypotenuse segment OB runs from the center out to B, so the hypotenuse is the radius. Apply the Pythagorean theorem to that right triangle. The radius squared equals the sum of the squares of the legs, which is 13 squared plus 21 squared. 13 squared is 169 and 21 squared is 441. Their sum is 610, so the radius squared is 610. Take the positive square root. R is the square root of 610. Since 610 sits between 24 squared and 25 squared, the radius is between 24 and 25, about 24.7. Here is the alternative method, using point D instead of point B. Draw a horizontal segment from O to the vertical side CD and call the foot N. Now triangle OND is a second right triangle whose hypotenuse segment OD is also the radius. The two legs of this alternative triangle come straight from K and H. Since K equals 21 and the line CD is at x equals 12, segment OEN is 21 minus 12, or 9. Since H equals 13 and D is at height 36, segment ND is 36 minus 13, or 23. Now apply Pythagoras again. The alternative method gives r squared equals segment OD squared equals 9 squared plus 23 squared, which is 81 plus 529, again 610. So both triangles give the same radius. So the answer is square root of 610. And there we have it, clean and verified. If you like walking through geometry this way, do me a quick favor and tap the like button. Then subscribe to GeoMethod so the next puzzle lands right in your feed. Have a slicker approach? Drop it in the comments. I read every one. Thanks for solving with me, and I will see you in the next one.